Welcome to Lesson 7, Solving Multi-Step Equations with Variables on Both Sides. Our goal, I can solve an equation, requires multiple simplifying and solving steps. So this is a very challenging lesson because we're trying to use everything we've learned so far on this one lesson. The biggest takeaway I'm seeing from your assessments is that we're still struggling a bit with the signs. I want you to use the operation signs frequently as positive or negative signs, and I will emphasize that during this lesson. So here are the steps we need to take. First, we have to simplify both sides of the equation. And we need these two steps. We use the distributive property to release the parentheses on both sides of the equation if necessary. Sometimes we're not given it on both sides of the equation. Then we combine all like terms before starting to solve. And we do this only if it's necessary. Sometimes it doesn't require term combining. However, we must do it in this order. If we're given both, we must do the distributive property first and then combine like terms. Our goal is to have on each side one term that has a variable in it and one term that is just a constant. We want to gather everything up so that we have a term with a variable and a term with a constant on each side. Sometimes we don't have terms on those two terms on both sides. We might just have one. Then we're ready to solve. If there are variables on both sides of the equation, we zero out or eliminate one of the terms. We usually try to eliminate the weaker or least term, and that's just to avoid negatives. Do we have to eliminate the weaker? No. We are just trying to avoid negatives in that way. It turns out that sometimes both of those terms with variables will zero out, and we'll talk about that in future lessons. Step 4, zero out the constant by adding or subtracting or eliminating a constant on one of the sides. And then finally, we divide or multiply by the coefficient of the variable. And I know that's a lot to take in, but as we complete this, I think it will become more apparent. So we're going to start with this first example, and we're going to follow our step-by-step guide. As I look at this equation, I'm just going to focus on this side right now. I see that there's a set of parentheses, so that's what I must do first. I must take care of the parentheses. So I want you to look and notice this is a positive 7. And you notice I just ignored the negative 4a. It's not in any way part of the distributive property, so I'm just going to drop it down. Positive 7 times positive a would be positive 7a. And now, once again, this sign is going to come into play. This is a minus 2. But we're going to look at it like it's a negative 2. And I'm going to take positive 7 times negative 2. And I'd put that in your calculator, but just to remind you, a positive times a negative is a negative. So 7 times 2 is 14, and it's positive times a negative, so it's a negative 14. And I'm going to write that as minus 14. So I've released the parentheses on this left side of the equation, and if I look, I don't have any parentheses on the other side of the equation, so I'm just going to drop down what is given. So we've taken care of step 1. Now we're going to go to step 2. Step 2 says combine all like terms before starting. Well, I'm going to build this wall, and we cannot cross over this wall until everything is simplified. So I'm going to combine negative 4 and positive 7, negative 4a and positive 7a. But I am not going to touch this 5a. It's on the other side of the wall. So it stays on this side. So negative 4 plus positive 7 would be positive 3a. So these combine to make one term with a variable, and that's 3a. This term is separate because it's a constant. It doesn't have an a, and there's nothing on this side to combine. I cannot combine it with negative 8. I cannot combine it with positive 6 because they're on the other side of the equation. So I'm going to just drop it down as minus 14. Now I can go to the other side. I prefer to start with my term with a variable. You don't have to do that, but I prefer to start with it. So I'm going to look on this side. This is the only group of, only term that has an A in it. It's plus 5A, so I'm going to write it as positive 5A. And now I have a negative 8, and this plus 6, I'm going to look at like it's a positive 6. So negative 8 plus positive 6 is negative 2. Again, I strongly encourage you to use your calculator. So now we've combined all the terms on the right side and all the terms on the left side. They cannot cross over that line. Now we're going to do step 3. It says if there are variables on both sides of the equation, we're going to eliminate one of the terms. And generally, we choose the weaker term. So 3a is smaller value, 3a compared to 5a. So I'm going to try to eliminate this term. Now I am ready to cross the wall, but I'm only going to cross the wall with an opposite. When we do this, we're doing a solving step, so it requires an inverse operation or an opposite sign. So if I have positive 3a, I'm going to write negative 3, or in other words, I'm going to take it away. So I'm going to take away 3a on this side, and this has to balance. I have to do exactly the same thing. This eliminates, and you notice this sign, so I have to drop down a negative 14. And on the other side, I have 5a's, and I'm taking away 3 of them, so I have 2a left over, and I'm going to drop down minus 2. So we're done with step 3. We've eliminated a variable on one of the sides. The next step says that we are supposed to zero out the constant, okay, by adding or subtracting. So this is the only thing on this side. So I'm going to start on the side with the variable, and the constant is the number without the variable. And I see minus 2. So once again, we're going to do the opposite. We're going to add 2 to eliminate it. It eliminates the 2 over there. And if I have negative 14 plus 2, that leaves negative 12. And I've eliminated the negative 2, so 2a drops down. So we've completed step 4. Now, last step is to divide or multiply by the coefficient of the variable. So I see 2a, and side by side means multiply, so we're going to do the opposite. We are going to divide by 2 on both sides of the equation. Again, this is a place we could get in trouble. Use your calculator or remember your integer rules. And our little story goes, if I have a negative and a positive, half awake or half asleep, we're mad. So we're going to put a negative answer, negative 6 equals a. So once again, the signs can really trip us up if we're not very, very careful with them, okay? So if I were to take time to do a check, if I inserted this negative 6 in where all of the a's are, both sides would be equal. And at this point, I'm going to skip over the check because this is a long lesson. Let's now go on. Make sure you have that copied down. Let's go on to the next example. All right, we're going to start by seeing if we need to use a distributive property to release the parentheses. And if not, we're just going to drop everything down that is not being used. So for instance, on this side of the equation, I don't see a set of parentheses, but on this side I do. So I'm going to go ahead and just rewrite what I see on the right side, the left side of the equation. I'm just going to drop down negative 5x minus 7 plus 3x because it didn't require the distributive property. But on this side, I can see it does, and it doesn't involve the first number. So again, I'm going to write down 4 because it's not involved in the distributive property. Now this is so important. See this minus in front of 3? That's so important. We're going to look at this like it's a negative 3x. So I'm going to take negative 3 times x, and that's going to be negative 3x. Very important again. Now I'm going to go back to that negative 3, and this time it's going to multiply a positive 1. Negative 3 times positive 1. A negative times a positive, half asleep, half awake, we're mad. So that's going to be negative 3. So we now have step 1 finished. Now we're going to go on to step 2 where we combine like terms. I'm going to start on the left-hand side, and I see I have negative 5x and positive 3x. So I'm going to put those together. Negative 5 plus positive 3 is negative 2x. And this term, constant, is all by itself. So I'm just going to write it, drop it down as minus 7. Now we're going to move to the right side. This is just my personal preference. You can start with the constants if you want. In fact, I'll go ahead and do that just to see. If I have positive 4 and negative 3, that's 1. And now I only have one term that has a variable, and so I'm going to drop it down along with its sign, minus 3x. Now, I'm going to write this above. You could have written this as negative 3x plus 1. Because it's positive 1, the plus sign travels with it in front, and because this is a minus 3x, the minus sign travels with it. So I could have written it this way. That's actually my preferred way, but I just wanted to let you know that that is a place you could write it the way I have it written now, and it's still okay. We just have to pay attention to those signs. So now I'm going to scoot this up a little bit, and we're going to go on to our solving steps. Our first solving step says that we want to eliminate if we have terms on both sides that have variables, we're going to eliminate the weakest one. Well, let's look at this. I see a negative 2x, and see this minus in front of the 3x? This is indicating this is a negative 3x. And since on the negative side of the number line, the furthest we go from 0, the smaller it is, we're going to try to eliminate this. The only reason being is we're trying to avoid negative signs, and this will do it at least in the short term. So I'm going to add 3x to both sides. We've eliminated because we did an opposite of subtracting, or opposite of negative, and now negative 2 plus positive 3 is going to give me a positive 1x. And I'm going to leave that 1 there for right now. We'll discuss that later. I'm going to drop down that minus 7. It wasn't touched yet. And the only thing that's left on this side is 1. So we have taken care of step 3. Now step 4 says that we should zero out one of the constants. And this is the only constant on this side. So I want to always look at the side that has a variable. Whichever side it is, it's the left side. So I want the minus 7 to go away, or you can look at it like it's a negative 7. And we do the opposite. We add 7 to both sides. Whoops, and I am left with 1x equals 8. So now we've completed step 4. Now I left this 1 here intentionally. When I dropped this down, I could have written this as just x. And you can, right now, 1x means just x. However, if this would have been a negative 1, I would have needed to use that negative 1 to divide both sides by 8. So if I continue and just go ahead and show that step, dividing by 1, then the answer equals 8. And that makes sense. If I have 1x, it's the same thing as x. However, here's where the problem might come in. If this was a negative 1, I really need to show that 1 because I'm dividing by a negative 1, and that would change my answer. So that was a what if. So let me erase that because it's not a negative 1. It is a positive 1. That was a what if. So what I'd like for you to try to do is I'd like you to go ahead and try the next 3 on your own. Would you please email me if you have any difficulties, and we'll go on from there. We'll try to address it during class time as well. Thanks so much. Take care.